Now, the client now has asked the server what is the IP address of www.microsoft.com, and the DNS server reply back. Now you can see that the exchange is very straightforward. I send a packet, I get a response. I send a packet, I get a response. Now this kind of very simple exchange of messages is typically called UDP, User Datagram Protocol. Okay, very simple protocol. Okay, it has no way to establish communications and so on. I just send a message to the server. The server responds to me. Very good. The server doesn't respond to me. I'll send again. Right. So that's how user datagram is. It's a very simple protocol. Now HTTP, on the other hand, is a much more complicated protocol. It's what we call a TCP protocol. Now, TCP protocol, okay, or the transport control protocol, okay, a TCP protocol must start with what we call a three-way handshake. Now, three-way handshake is like this, right? A client will tell the server, I would like to communicate with you. So I will send what we call a sync. I'll send a sync to the server. Okay, I'll send a sync to the server. The server, upon receiving this, will say, okay, I acknowledge that you are trying to communicate with me. Right? So I will send a sync plus acknowledgement back to the client. And then the client will say, okay, I got you. I acknowledge your acknowledgement. Right? So this is what we call a three-way handshake. Right? So there's always three packets that's been sent. After the three packet is being sent, communication is established, and a TCP communication can now start. Okay. Now TCP communication is typically what we call a streaming communication. That means we expect this communication to be long lasting. Right? Just as a browser expect the browsing this server to be a long running connection. I'm not going to request for one piece of one paragraph and then I disconnect from you. No, I'm going to request as many things from you as possible. If I need to click on certain links and this link is happen to be on your server, I will continue to use the same channel of communication to talk to the server. Okay, that's why we use a TCP for this kind of connectivity. And TCP, it is also a self-correcting protocol. Within the TCP, there are many things that we do, such as windowing and so on, sliding windows, that allows error correction. So I can send certain packets. If this packet is lost and so on, it will self-correct. The TCP layer will actually self-correct without the application layer noticing. So the browser doesn't need to care. The browser just says, I'm going to send this, I'm going to receive this, okay, and the underlying layer, the underlying TCP layer, will handle all this correction. For UDP connection, just like the DNS, it doesn't, right? So if the client detect that, oh, the server is not responding, the DNS server is not responding, it will have to resend by itself, right? So the error correction has to be done by the client, right? So that's the clear difference. Now, from an application perspective, which protocol to choose? There are some ways you need to determine. Like for example, if it's a long-running transaction, we know that we are going to connect to this server for a long time. We're going to have a lot of exchanges of messages. then TCP may be the way to go. For a very simple query, then UDP may be the way to go, because we don't want to use too much network traffic overheads to handle all this error corrections and so on. We know that it's just a simple send and receive, right? And if there's error, we can either ignore it or we can just do a simple resend. Okay. Now those kinds of communication we can use UDP, right? Again, those are advanced topic. Do feel free to search the internet for any informations for information on TCP and on UDP itself, right? Now, three-way handshake. It is the start of a TCP communication. It is also a point of note for adversarial thinking. Now, imagine as a browser or as a client, I send a sync to the server, and the server look at the sync and say, oh, okay, somebody is trying to communicate with me. And the server will do some setup, right? Says, okay, I'm going to set up some connections, right? And I'm going to send an acknowledgement back. Now, in this case, the client will just ignore. The client doesn't complete the third sync, the third acknowledgement. Now, if this kind of things do happen, like for example, the connectivity drop, or the user happen to like close the browser, now it happens, right? So the server will look at the sync, you send the acknowledgement, and then you will like keep waiting for this acknowledgement to come back, and so it use some resources to wait for this acknowledgement, and after some time you will time out and say, oh, okay, something must have happened, right? Then it drops it drops the data structure, and life goes on, right? So those are okay if it's like it happens once in a while. But what if this kind of things happen many times in a very many times within a very short time? And this is what happened. It's what we call a DDoS attack. The DDoS attack, or one of the very simple DDoS attack, is a three-way handshake attack. Meaning, you can have a lot of browser or a lot of client sending sync to the server, and just after that, completely ignore any response. That means you just send and forget. Now, to the server, it is just it looks as if a lot of query is coming in. There are a lot of connection that is trying to do, right? Now, many times, if this thing happens a lot of time within a very short time frame, it will jam up the server. And this is what we call a denial of service, right? It could be, let's say, for example, this is google.com, okay? www.google.com. And if many people are trying to send a sync to google.com without acknowledging it, and google.com is spending a lot of resources waiting for this kind of request, it may actually fail to service legitimate user. So a denial of service is kind of malicious, because it actually deny a legitimate user the right of the server, right? So it is a bad thing. It's a bad thing, and a lot of time, malicious people use denial of service to ransom service provider, telling them that okay, if you don't give me something, I'm going to keep attacking your server, so that your legitimate customers cannot use your service, right? So that's a denial of service attack. Now currently there are of course many ways that we can mitigate this kind of attack from the network, such as traffic shaping and so on. But do keep that in mind. This is how attack could be formed. Attack could be formed in many ways. Attacker will look at a very legitimate part of your protocol and think of funny ways of using it. Right. So as a cyber defender, the adversarial thinking is when you look at a protocol, when you look at this legitimate pattern, you think about how would some other patterns be used. How, if I miss some of these things, what will happen to the server or what will happen to the client? And this is a very good thought process as a cyber defender. Okay, this way of thinking about normal protocol and how this normal protocol can be compromised into something malicious. Right? So this is a three-way handshake. Right? So we can see that the server actually started, the client actually started 1 cent, okay, starting from packet number 5, it actually sends the first packet, which is a sync packet, and then the server respond with the sync acknowledgement packet. So 80 sends to 62955, and then 62955 sends acknowledgement. So there's a sync ack, and then acknowledgement. Right, again, over here you see that there are actually two channels that Chrome has set up, right? The 62955 channel and the 62956 channel. It set up two channel of communication with the server, and the server actually responds and says that, okay, this two channel is open for you, right? But in the subsequent packet, you'll find that it actually only uses one. All right, the other one is used for backup. Okay, so let's take a look at the sync packet itself in the three-way handshake. Okay, it's a very small packet, only 68 bytes itself. And the most important part is that in the flag area, in the flag byte, the sync bit is being set. So we know that this is the sync bit, right? No acknowledgement, it's just a sync. And in the acknowledgement packet, you'll see that the acknowledgement is 1. Let's look at the detail itself, right? Let's look at the detail of the packet that is being sent back from the server back to the client. Okay, the flag has both the acknowledgement and the sync set, right? And it actually will, if you can actually trace back, you actually the acknowledgement number, this number is the same as the number that is being sent in the sync packet. So very interesting series, okay? And Wireshark actually used the sync sequence number to construct what we call a conversation, right? Just now I talked about Wireshark has this conversation list, and the conversation is actually any streams of exchange that has the same, that follows the sequence number, right? So you can actually trace from the starting packet, starting from the sync packet all the way until the last packet, the acknowledgement of the various packets will actually be in sync. Right? And then we will look at the last packet that's been sent from the client to the server. It has no sync, it only has the acknowledgement. Right? So this is the acknowledgement flag.